Hey everyone, in this video we're going to be looking at the big ideas for section 8.4, and they're really pretty similar to what we've seen in the past. So in this section we were looking at a two-sample z-test for the difference between proportions. The first thing that we need to know is this about the hypotheses. The null hypothesis will always be equal to 0 because we're checking to see that it is equal. We're checking to see if there is a difference between the two parameters. So it's always going to be equal to 0, which basically says that there is no difference between the two. Then the alternative hypothesis could be anything, it could be any one of these three. It could be less than, greater than, or not equal to 0. And once again, less than means that one of them is bigger, one of the two parameters is smaller, greater than, one of the two parameters is larger, or not equal to, we're just checking to see if there is a difference. We don't have any kind of direction. So with the conditions for this particular hypothesis test, the conditions are exactly the same. We're still going to check for randomization to make sure that both samples were collected randomly. And really, another part of that we could put in there is that they were independent random samples. So you could put independence in there as well. We also are checking to make sure that our sample size is not larger than 10% of the population size. And we also need to check the large counts condition. Now for all three of these, we need to check all three of these conditions for both samples, the 10% condition for both samples and the large counts for both samples. And then finally, the last part of our big ideas is the test statistic. So to go through this test statistic again, remember our generalized formula for a test statistic is the statistic minus the parameter divided by the standard deviation. So our statistic is the difference in the sample proportions. Our parameter from the null hypothesis is going to be equal to 0. And then we get to the standard deviation. And this formula, the biggest part of this formula for the standard deviation for the difference between proportions is this part right here. We are assuming that the two parameters are equal to each other. We're assuming that if we subtract the two, it will be 0, and we're assuming that from the null hypothesis. Whenever that is the case, the formula for the standard deviation looks like this. This is where we put our two proportions together. This p hat is when we put our two proportions together and do this times this. So this is a slight difference from the standard deviation that we use when we are trying to create a confidence interval for the difference between proportions. And we need to make note of that. So hopefully these big ideas help you understand things just a little bit better and they clarify some things. And hopefully you have a great day.